What should we expect when expecting robots? I'm Tonya Hall, and joining me is Dr. Julie A. Shah, author, associate professor of aeronautics and astronautics, and leader of the interactive robotics group of the Computer Science and Artificial Intelligence Laboratory at MIT. Welcome, Dr. Shah.
Thank you so much for having me.
You just co-authored a new book titled What to Expect When You're Expecting Robots. Great book name, by the way. What motivated you and your co-author to write this book?
Well, in terms of my day job, I'm a professor at MIT, and I'm an AI researcher and a roboticist. And I work on trying to make robots into better teammates, reverse engineering the human mind to make robots that understand people better and are better able to collaborate with us. And I've spent many years developing and deploying robots that, for example, work alongside people in factories to help build planes and build cars. I am faculty in the aerospace department, and I would just say is a little bit of a different tack than the traditional roboticist. Also have a great appreciation and a background in human factors to understand how you will only get so far if your end goal is to make a more independently capable robot or capable system. And that we really need to develop these systems kind of in concert, make them more capable, but make us more capable of collaborating with them, and really think about how we adapt society. We need to change our norms so that these systems can really integrate and provide value to us. Many years of thinking deeply about what it takes to make systems that sort of like fit tightly with people to collaborate in factories. And now my co-author Laura Major and I are passionate about taking those insights and beginning a discussion of how we really need to re-envision society so these systems can break out of the factories, break out of these sort of more specialized environments, and be more useful to us in our everyday lives.
So, regarding robots of the near future, you wrote the following: whether they make our lives better or worse comes down to whether they know how to behave. How should robots behave, and how will they learn this?
Yeah, so any one robot, it's okay if it's clumsy, right? If it's a little clumsy, or we have to, really change the way we think about the system or how we interact with them. So think about like your Roomba in your house. It's a beautiful robot. It's so beautifully designed. It's simple. It does exactly what you need it to do, but it kind of bounces around. It'll knock into your foot. Doesn't really sort of see your home or your world, and that's okay if it's one of them. But now, imagine a world in which you're surrounded by these systems in your home as you try to make your way to work, walking down the street, at a crosswalk, in your office. At scale, small frictions at scale can cause very big problems. And that's why it's really critical that we get this right. We think about it now when these systems are small numbers, and we build a path to ease their introduction in society, and also think about sort of the disparate impacts or the disparate benefits that we'll gain from these systems.
What are the biggest challenges facing robot designers today when they're creating robots that must operate around people?
Well, there are many challenges on the technology side and on the human side. One is when we think about bringing these systems into our lives, if we think about the success of other AI systems today, other machine learning systems, it's highly dependent on the way we structure that system's understanding or learning of our world. And we might think these deep learning techniques are learning on their own, but we structure what they know about the world through painstaking efforts of labeling, for example, data sets. Sometimes we do more than that. We give sort of explicit models of causal relationships that the system uses to bootstrap its learning of the environment and of people. What we can give systems today about our everyday world is quite impoverished. So sidewalk delivery robots, they don't really see you as a person. They see you as an obstacle. And that might sound okay, because as long as it avoids you, you can go about your business. But it's not actually okay. And to give you a sense, sort of the canary in the coal mine, about 2 years ago, and of course, San Francisco, there were actually so many startups testing sidewalk delivery robots that, that people felt unsafe. The elderly, people with disabilities sort of went to the city and said, you know, these systems don't understand us. We feel unsafe near them. And you know, why is that? I mean, the system doesn't understand someone who's moving slow for any reason, pushing a stroller or otherwise. We're not obstacles, and we could never interact in our own everyday life by just treating another person as any other, you know, type of obstacle. And so we don't have these, for example, data sets on social interaction about what makes someone uneasy or what makes someone take a wider berth. And that's just kind of one example. We really need to be rethinking, you know, how we design these systems, the data that we collect. And then similarly, we need to be thinking about what's transferable or shareable. When you know, if a security guard robot knocks over a toddler in a shopping mall, which is something that happened, you probably saw it in the news too. That's just as bad as an autonomous vehicle hitting someone on the road, right? That's a critical incident, a potential life at risk. And so what, you know, any one company can do an analysis and try to patch the issue, try to identify gaps in the data used to train the system. But it's what can we do to facilitate transfer from one manufacturer to another, from one company to another, to ensure that as we roll these systems out at scale, they're safe. We do this in aviation. We do have systems in place to share information across many different entities, industry and government. And so we need to get started right away to think about how we set up these sort of structures to get this right in our everyday lives.
I've interviewed many robot designers that went to great lengths to make their robots look attractive, approachable, even friendly. But you say that robots don't have to be cute. Why not?
Well, and again, you know, coming from aviation, I often hear people talk about how we need trustable robots or we need trustable autonomy. For example, in many critical fields, search and rescue, military operations, you know, sometimes people don't want to use the AI or the autonomous system. They don't trust it. And so a key question is, well, how do you engender trust in the system so that people use it? Now, a key thing we know about the design of cockpit automation is that, you know, your end goal is not actually engendering trust in a system, especially a safety critical system. It's very easy to engender high trust in a system that doesn't deserve it. And so to overtrust a system, and that's the result of, for example, many aviation accidents. The key here is to figure out how we design these systems to facilitate calibrated trust in them, so that a person can easily track when a system is behaving as it should, when it can be relied upon, and when it's not, when sort of the way it's behaving or the information it's providing you is no longer high quality. You equally want a person to be able to track that degradation in the performance of that system and know when to reject or intervene with the system. Personalization of robots, it engenders trust. So if you give a system a female voice, it engenders trust. If you, there's many things we can do that are very easy to engender trust, but the question is, ought we to, and how do we calibrate the way the system interacts with us so that we can calibrate to it as well?
Dr. Julie A. Shah, Associate Professor of Aeronautics and Astronautics, leader of the Interactive Robotics Group of the Computer Science and Artificial Intelligence Laboratory at MIT, and co-author of What to Expect When You're Expecting Robots. If somebody wants to connect with you, Julie, maybe they want to get a copy of your book, what's the best way they can do that?
Well, you can check out my lab's research at interactive.mit.edu. Follow me on Twitter, and also track the work of the Schwarzman College of Computing, where I'm actually Associate Dean of Social and Ethical Responsibilities of Computing, where we're thinking deeply about the intersection of technology and society.
Sounds great. Thank you so much, Julie. And find more of my interviews right here or at tonyahall.net. Thanks for watching.